The standard for today is NSO.1.2, which states read and write multi-digit numbers with decimals to the thousands using standard form, word form, and expanded form. Now, before we get to breaking that down, let's go back to understanding this place value chart. Just as a reminder from a previous video, on the left side of the decimal, we have our whole numbers. And on the right side of our decimal, we have our parts of whole numbers. And these are all connected by that decimal, and we use the word and. Now, below we have an example just to review. If you look at this number, we focus on the decimal. On the left side of the decimal, we have our whole number, which is 223. And on the right side of the decimal, I see the number 12. So when I read this number, on the left side, we can just say 223. And on the right side, we have the number 12. However, we have to identify what place value that 12 represents. So we look at the very last digit, which in this case is a 2, and we figure out what place value that 2 is in. And if we look at our place value chart, that 2 is in the thousandths place. So if I was to read this number correctly, I would say 223 and 12 thousandths. There are 3 things we need to understand when it comes to this benchmark, and that is standard form, word form, and expanded form. So up here I have a number that is written out, and standard form is the decimal version of the number. So when I look at this, I have the number 15 and I have the number 23. So in standard form, we have 15 and we have 23, and this last place value is in the thousandths place, which means this is 15 and 23 thousandths. And that is written in standard form. Another way that we can write numbers is in written form. So when we say a number out loud, we can just write down what we say if we say it correctly. So again, if we look at our number in standard form, I can see that on the left side, we have 15. So that is our whole number. We have 15 wholes. And this is separated by a decimal. And we say the word and because we have whole numbers and we have parts. So I have 15 and I can just read this number as is. That number says 23. So I have 15 and I have 23. And finally, we just look at that last place value spot right here. And that 3 is located in the thousandths place. So I write thousandths. So when we write it out, we say 15 and 23 thousandths. So we have standard form and we have written form. And the final way to express a number is going to be in expanded form. Now I'm going to show you 2 different ways we can write it in expanded form. We have a decimal version and we have a fractional version. So expanded form is a number broken down by place value. So if I look, I have a 1 here. So that 1 is in the tens place. So I can say 1 times 10. So I have a 1 in the tens place. I also have a 5 in the ones place. So I can say 5 ones. I also have, I don't have to write anything for 0, but I have a 2 here. I have a 2 in the hundredths place. So in decimal form, I can write 0.01 for our hundredths place. And I also have a 3 in the thousandths place. So we're expanding a number out by place value, and we represent it this way. If we want to do it as fractions, we could say, once again, with our whole numbers, we can just continue with our whole numbers. We have 1 in the tens place, We have a 5 in the ones place. Now, when we get to our parts of wholes, we can represent, we have 2 hundredths, as you can see up there. And we also have 3 thousandths. Now, let's go into some sample questions. So, our first question here, which representations are equivalent to 312 and 61 thousandths? So a strategy I use to solve this question is to make my own place value chart. So what I mean by that is I stay organized and I write little blanks here to represent my place values. It helps me keep organized as I'm solving the problem. So the first thing I want to do is I want to recognize this written form of a word, and I want to put it in standard form, because standard form is what we all recognize. So if I was to do that, I'm going to focus on the word and, because and represents our decimal, right here. So when I'm reading this, I look on the left side of the decimal, and with words, it'll be on the left side of the and. 312. So all I really have to do is write 312. For a whole number, you just write what it says, 312. And, which is our decimal, and I have 61 thousandths. Now, thousandths is our place value, so I'm focusing on the number 61. 61 should look like 61. But the thousandths tells us where to put the last digit of 61. So we have to identify the thousandths place. And if remember, we have tenths, hundredths, thousandths. So when I write 61, we're going to put 61 where that last digit is in the thousandths place. And since this is blank, there's nothing in it. So we represent nothing with a 0. So the number we are looking for looks like this, 312 and 61 thousandths. So now what I want to do is I want to break down each one of these potential choices to see which one matches our number in standard form. This first one right here, this says 312 and 61. But if you notice, the last place value is in the hundredths place. So that's 61 hundredths, not 61 thousandths. So this first choice cannot be correct. Now, as we go on to B, this is a version of expanded form. So to help me understand, I'm going to make those blanks to make sure it matches my number. So right now on my whole numbers, I have 300, I have 10, I have 2, which equals 312. So I'm going to go ahead and write that 312. Now, when I get to the right side of my decimal, and we understand these are parts of wholes, I notice fractions are parts of wholes. So this one says 61 thousandths. So again, when we hear the word thousandths, that's where our last digit goes in 61. So 61, last digit, thousandths place. We fill in any empty place values with a 0. So we have 312 and 61 thousandths. And that matches perfectly. So B is one of our choices. Okay, this is more than one answer to this because we have a lot of multiple select questions this year. All right, part C. This one's long and expanded out, so I want to write my place values out just to help me stay organized. Okay, now this one's broken down by place value. So I have 3 times 100, which means I have 3 100ths. So I'm going to find my hundredths place, and I'm going to write a 3, because I have 3 100ths. And plus, I have 1 10, or 1 times 10. So I have 1 10. And I have 2 ones. So I put a 2 in the ones place. Now, as we get to our parts, they're represented as fractions. So I'm going to look at this first one. This says 60 hundredths. So the hundredths place is right here. So when I write 60 hundredths, the last number in 60 is 0. So when I write 60, I write 60 hundredths. And then finally I have 1 thousandth. And I write a 1 in the thousandths place. So after I finish breaking down this number and putting it back in standard form, we have 312 and 601 thousandths. So this one is incorrect. On part D, since it's not in standard form, I'm going to make it in standard form. Once again, I have 300 plus 10 plus 2. Those are all whole numbers, so they go on the left side. 300 plus 10 plus 2, 312. And I have my parts. So here I have 0.06. It's already written in standard form, so I can just plug in where 0.06 would go, which would be here, 0.06, or 600ths. And then I have 1,000ths, and then I can fill in my 0. 312 and 61 thousandths. So this one is correct. And then we have E, which is already in standard form. We just want to see if it matches our written form that we already did. And as you can see, it says 312 wholes, and I have 61, and that last digit is in the thousandths place, just like when we solved it at the beginning. So part E is also correct. So after breaking it down, staying organized, which is essential in math, we have the answers of B, D, and E that all are equivalent representations of our written form. For question number 2, we have write this expanded number in standard form. So we're still focusing on the standard with standard form and expanded form and how to go back and forth. So what I see here is this expanded form is broken down by place value. So how I want to solve this is using my strategy of making your place value blanks. So we have a template to work with. So I'm going to start over here at 9 times 10. This just means I have 9 10 times, or a 9 in the tens place. So I'm going to find my tens place. So here's the ones, and we have the tens right next to it. So I'm going to put a 9 in the tens place. Plus, it means I also have 3 times 1/10, or 3 tenths. So I can find my tens place, which is right here, and I could put a 3 in the tenths place. And finally, I have plus, or also, 70 thousandths. So I have to find my thousandths place, but since this is a 2-digit number, I want to put the last digit in the thousandths place. So if I'm writing 70, I can't write 70 over here. I have to write the 0 and put the 7 next to it. Now, once you're finished with your expanded form, you could go ahead and fill in your empty zeros within the number. And this number that's in expanded form, in standard form, is 90 and 370 thousandths. For question 3, we have which choices below are equivalent to 312 and 61 thousandths. So we have word form here, and the easiest way to determine which of these is equivalent is to put it in standard form. And how we do that is make our place value blanks and look for the representation of the decimal, which in this case is and. So on the left side, which is our whole numbers, we have 312, and we can write that just how we say it, 312. I'm going to put that on the left side where the whole numbers go. And, which is our decimal, 61 thousandths. Thousandths is our place value, so we're looking at the number 61, and it's going to look just like a 61, and we're going to put that last digit of 61, which is 1, in the thousandths place. So I put a 1, and I will put a 6 next to it. Now, for the rest of it, we have a 0 or nothing here, so we're going to fill in that blank with a 0. And we end up with 312 and 61 thousandths, as we can see. Now we're going to go step by step through our choices here and see all the ones that are equivalent. First off, we can start off with A, and we can notice that A is not going to be the right answer because this says 312 and 61 hundredths. So that is not correct. For the next 3, we're going to go ahead and use our place value blanks. So if we look on the whole numbers, which is 310 and 2, those are all whole numbers. We can combine those together and we can get 312. I can go ahead and write 312. Then we have a part. Our fractions and our decimals are our parts. This fraction says 61 thousandths, and we still have to follow that rule where the last digit is put in the thousandths place. So we find our thousandths place, and we put the last digit in 61 right there. And we fill in all of our missing values with a 0. We have 312 and 61 thousandths. As you can see, it is a match. So we can go ahead and say, yes, B is a correct answer. Now for C, go ahead and make your blanks. Start off with, now this is all expanded form, so we can start from left to right and just fill in our place values as we go. 3 times 100 means 3 100s, or a 3 in the hundreds place. Here's the hundreds place, write a 3. We have 1 10, or 1 in the tens place. So we find the tens place, we put a 1. We have a 2 in the ones place. Now, as we get to our parts, we see our fractions, which are our parts. We start off with 60 hundredths. So I'm going to find the hundredths place, and rule applies, the last digit goes in the hundredths place. So we have 60 hundredths, and we have 1 thousandth to finish it off. And if you look at this, it does not match our original answer. This one is 312 and 601 thousandths. And then we go to D. We have 300 plus 10 plus 2, which are our whole numbers. We can combine together to make 312. And then with our parts, which in this particular choice is represented as a decimal, I can read this number as 6 hundredths. So I can put a 6 in the hundredths place. And this one right here is 1 thousandth. So I can put a 1 in the thousandths place. And I'm going to fill in my 0. 312 and 61 thousandths, which is a match. And finally, we have the last choice of E, which, as you can see, is the right answer because it has 312 on the left side and it has 61 thousandths on the right side. So that is the correct answer. So that is our overview of NSO 1.2. Let me know if you have any questions.